Well, good afternoon or good evening. Let's get started today and talk a little bit about video and mathematics, or how video can further personalize or blend instruction for individuals that are trying to address mathematic issues. Now, video itself is powerful, and there's a lot of different ways video is being used in instruction, and many of us will immediately think of the Khan Academy. But I want to kind of explore also kind of global issues we know about video-based tools for instruction. And of course, video has been around for years, but it's become very specific to the use in personalized or blended learning. And before we finish here, I want to talk very briefly about Video Plus and some options that go beyond many of the things that we think about, and that is pre-constructed video that is available to us for instruction. But that is where I'll lead. Now, with that said, let's kind of start thinking about video totally separate from math, but from our own learning experiences. And I imagine many of us will connect with this one.
Woo, you sure gotta climb a lot
Oh,
of
and
steps
feel free to
get to the
sing
Scaffold
along.
Building here in Washington. Well, I wonder who that sad little scrap of paper is.
I'm just a bill. Yes, I'm only a bill. And I'm sitting here on Capitol Hill. Well, it's a long, long journey to the capital city. It's a long, long wait while I'm sitting in committee. But I know I'll be a law someday. At least I hope and pray that I will. But today I am still just a bill.
Now feel free, guys. Continue singing, or come on, conjunction, junction, what's your, that's right, function. Now I share this because it has nothing to do with math, but it has to do with the video and has to do with how hopefully some of you are making that connection between your own learning experience and the fact that you could probably now tell me about the sequence of the bill and how bills become laws or not become laws, and veto and the Senate and the House of Representatives and the like, all with a 3-minute video. Now there's other instances where video, without even us setting the stage for the individual, they can watch something and pull out elements that are there that would take us much longer to try to either explain, contextualize, or be able to kind of make that connection for generalization. Here's one in my instance, has nothing to do with math, but I think it's a fun one.
It's scary. Oh, there's cars coming. Oh, there's cars. Ah! Bill, just put me back for me control it. Oh, dear Jesus. I could never. Oh, where's it going? God damn, Bill. Oh, my God. Oh, this is so scary. Oh, Jesus, this is my first day out and I'm about to die.
Oh, come on, relax.
Oh, my God, Bill. I couldn't do it. Oh, is the car coming?
All right, sorry about the language from Grandma, but the idea here is that without me explaining this, you'll immediately would say, well, she's driving a driverless car. She has a passenger in there. And more so, you'd say that that's not on a local street going 20 miles an hour, but it's also not a highway going 65, 70 miles an hour. Looks to be a 2-lane versus a 4-lane. She's clearly upset. She's not aware, and et cetera, et cetera. But I haven't had to introduce that. You made that connection. And by the way, just when we talk about driverless cars, which are becoming more popular, this is probably more of us, right?
How you're playing patty cake. Or how about these guys? As their Tesla cruises along, they're playing games like Jenga. Too exhausted to drive? How about a little shut-eye? And check out this road trip. Playing cards, arm wrestling, reading books. We found several...
All right, enough of that, Sean, about this. The whole purpose here is not so much about driverless cars. It's nothing to do with driverless cars. It has to do with the power of video, and it has to do with video as a best practice. And there is some good literature and good research on elements that align themselves to instruction that video can foster and video can further facilitate. So for example, out of this, the Institute of Educational Sciences, What Works, makes a number of connections between anchored instruction, between regular practice and repeated practice and reflection. John Hattie's work in visible learning, which aligns itself to a number of different things that, again, align themselves to the need for video. And then finally, teaching works, and that was high leverage practices. Now, the University of Michigan, with a number of other affiliations, has created basically 19 high leverage practices, or I should say identified 19 high leverage practices. And the idea of these high leverage practices is that if teachers were to be taught these, pre-service, in-service, what we're finding is that if they were taught and applied these, it goes a long way to including all learners and addressing the needs of all learners. Now let's take a look at number 14, and you're saying, Sean, this has nothing to do with video. It doesn't say video in there at all. You're correct, it doesn't say video in there at all, but it has a lot to do with video, especially the way video is used in math instruction. It sequences lessons. It basically provides a structure for practice and mastering the foundational concepts and skills. It offers not only a sequence of lessons, but coherent focus. It engages the students. It makes a connection. It allows the individual then to, from one sequence to another, to allow for skill and then practice of that skill. Practice, of course, being away from the video, but practice does go on in the video. So that is just one element of high leverage practices that align themselves very nicely to the use of video, especially in math instruction. Now there's other tidbits that come out from math instruction, but also video instruction. And let's start with video. First of all, the video element, we know it anchors, we know it contextualizes the learning. It gives the individual something to hold on to. It engages the learning, and we know it does assist in mastery learning. We also know educational video allows, depending upon how we use it, creates an experience. It potentially enhances the typical lesson and builds upon it. It allows definitely an individual to revisit a key concept, and it changes that teacher from a teacher more so to a facilitator. Finally, when we're actually watching the video, we know that if the student is actually working and watching, making a connection, reflecting as they watch, and of course, looking for areas where, okay, I want to repeat that, I want to target that, there's a purpose behind the element, and of course, we're using that instructionally as well. A lot of good outcomes can come from that. So let's think of that, and let's apply that to some of the math lessons that are video-based out there on the web. Let's start with some free ones. So this is one off of Patrick. He offers a variety of different things, and we'll just introduce this one real briefly.
Really hard. So I look at the first number, 6 and 2. I think, will 6 go into the number 2, a whole number?
So he's kind of walking us through.
Then we do the same thing. We just subtract. So 15 minus 12. You could at this point stop and...
All right, so what he's done here, and I've been fast forwarding, is he introduces with a simple whiteboard and a magic marker, actually 3 different colors. He's walking us through the concept. He's walking us how we should be thinking about the equation and solving the equation. He's giving us elements in terms of structure and color, in terms of what we should be concentrating on. Now, allowing here, he's kind of making a connection here. He's allowing for some flexible understanding here. He's revisiting key concepts on each and every step, and you're like, Sean, well, we can do this when we're actually teaching face-to-face. Well, sure, or we could do this synchronously online. Yeah, but it also allows me to stop, as I have, and say, wait a minute, I want to revisit that concept. Wait a minute, I want to have a little more independence and going back and taking a look at this at a little bit slower speed to understand I'm confused on this one element. It allows me potentially to reflect as well, depending upon how I have facilitated the learner in their watching a video. So all that is there for me as I reinforce. Now, Math Playground also offers a variety of these resources, and here we'll just watch him do something similar.
We need a formula for a pentagon.
Okay.
Pentagon, we can draw in 2 diagonals from one vertex, and now we've created 1, 2, 3 triangles. So we have...
All right, and in this instance, we have the same type of thing going on. Now here we have 3 columns. We're using color here. And again, this is something we could do face-to-face, but we don't have that option. Or even with the face-to-face, this allows me particularly to stop, reflect, go back. I'm active in my engagement, in my watching. I'm in control of that, even from a typical lesson that is something that we would potentially see in a class face-to-face, but it's altered it by creating it in video. And by the way, we can control the language. We can be very purposeful in what we say or don't say. We can illustrate. We can go back and re-record, or at least when we're watching the video that we're going to select, we can select the video that we think is most appropriate. Now, with that said, let's kind of continue on with some of the videos that are out there. In this next video, this is something that we have available to us, this is off of the Discovery Learning or Streaming, and a number of different videos for us to kind of take a look at and explore. But one I want to share with you that's a little different from what we've been introduced to up to this point is, well, this is an introduction to exponential functions, okay? And so, well, here, let's take a listen.
The amount of money accumulating over time in an education fund, the geometric construction of colorful shapes called fractals, the number of bacterial cells growing in a laboratory culture, and the amount of time it takes for soup to go from scalding to edible. All these changes can be described by exponential functions. Indeed, exponential functions are used to describe those and other interesting processes in fields such as chemistry, biology, physics, economics, and finance. We'll delve into some of...
So here we are talking about exponential functions, but from that she's introducing it without a formula in sight, minus the ones, of course, that are in the background, and contextualizing it within things that are hopefully relevant to us, and of course in other content areas. Now as you scroll down here, she'll start walking you through everything from graphing and exploration, and she'll use a graphing calculator, to walking us through the actual formulas and how they all generate. So for example, here's one that talks about our basic equation, and it's illustrating it through what we would normally see in some of our previous videos. So here we go.
20 minus 8 equals 12. That's an equation. 2 times 7 equals 14. That's an equation. As you can see, both sides of an equation have to equal each other at all times. So if you make a change to one side of the equation, like adding 8 to this side, you have to add 8 to the other side. Same goes for all operations.
So here she's introduced the basic idea of an equation, and she's doing it in a manner that's similar to what we just saw in other illustrations. So there's a number of different ways we're seeing video being used in math, but very typically we're seeing it in the manner I've just illustrated in a number of different resources. And again, they reinforce what we know does work. Now, I've stopped here for a moment because I want to reinforce the fact that while there's a number of things that have been pre-made, there are things that we can make ourselves, and that's something we'll get into in the next section of our presentation after we take a brief break. But before we get to that brief break, let's of course get to the video that we all tend to think about when it comes to math instruction, and that's the Khan Academy. And let's take a brief look and listen to some things he's doing for rational numbers. So here we go.
-5, and so on and so forth. And then we get to 0, which is one of the numbers that we've already written down. 0 is obviously right over there on the number line, so I'll just write this 0 in orange to make it clear it's this 0. Then we have 20 is 1 and...
All right, so you can see here he's using a number line. I could go closed captioning. He's identified rational numbers. He's identified numbers, and in each number he's introduced, explained. He's color-coded them, turns a circle and putting them on the timeline. He just walked us through, even though I fast-forwarded, an element of division. And when he did division, he explained what he was doing and why he was doing it. So all that's captured when he's trying to explain rational numbers. I can stop, I can review, I can listen. And of course, I have closed captioning, so actually, if I wanted to, see and hear the words, hear and read the words as I go along as well. Now, as we kind of conclude this first part on video, I want to reinforce the fact that yes, video offers so much. It offers the ability to anchor. It offers that flexible learning. It allows us to revisit key concepts. It allows for independence. It allows for reflection. It allows for an active process when we're actually watching it. But video, not all video is created equal. And even in Khan Academy, there's concerns with video. And so let me give you this last illustration, and then let's get thinking about an activity when it comes to video. So here's a last illustration with basic arithmetic, where he's using manipulatives. And let's just take a listen.
You are to give me another avocado. How many avocados do I now have? Well, let's see, I have 1, 2 avocados. So 1 plus 1 is equal to 2. Now, I know what you're thinking. That was too easy. So let me give you something a little bit more difficult. I like the avocados. I might stick with that theme. What is 3 plus 4? This is I think a more difficult problem. Well, let's stick with the avocados. And in case you don't know what an avocado is, it's actually a very delicious fruit. It's actually the fattiest of all the fruits. You probably didn't even think it was a fruit even if you ate one.
Now, this is one of the elements that is a concern with Khan, but also other videos as well. Remember, I said video has the ability to focus. Video has the ability to really focus on the purpose of what we're trying to do instructionally. Well, the first time I heard this, Corona had an advertisement for beer, where if you were drinking a beer, you would envision yourself on a beach, and you'd be all relaxing, regardless of where you were drinking the beer. Well, when I first heard this, I quickly was drinking a beer on a beach. And how did I get there? Well, he mentioned avocados, and avocados to me is guacamole. Guacamole to me is guacamole and chips. Guacamole and chips, you have to have a beer. Well, I'm drinking a beer, now I'm on the beach. Now you're like, well, I hope our young children thinking about arithmetic are not thinking about beers on the beach. No, but most likely they're thinking about, oh, avocado, it's a fruit? I didn't know it was a fruit. Fruit. Geez, it's before lunchtime. I wonder if I'm going to have apples. No, grapes. I hope Mom packed instead those cherries that I like, or maybe it's that banana I like. So next thing you know, I'm distracted. I'm cognitively processing something that has nothing to do with mathematics because he introduced something that had nothing to do with mathematics. The manipulative was powerful, and that's the circle. He then took it to a direction he didn't need to. And that's where we tend to get distracted with the video and distracted with that instruction. And that's something we need to be really thinking about with that cognitive load, which I'll talk about in our next session. So with that said, there's a number of different things that reinforce what we know about good instruction with video in education, and of course its alignment to math. I hope with my brief introduction, I made those connections. And as we kind of go into our activity, I want us to actually create our own video. And here's a brief little illustration of what I want us to create. Now, I'll get us started, and then there'll be a link for this for you to watch at your leisure. And this illustration is simply how to create a paper slide video.
How to make a paper slide video. What is a paper slide video, you may ask? Well, hopefully by the end of this short clip, you'll be able to answer that question as well as how to make a paper slide video. Step 1, you'll want to make sure that you get organized.
There you go, folks. You take sheets of paper, you fill out whatever you want to be able to capture. You have a phone or whatever that you're capturing it with. You slide the papers through, and next thing you know, you have a video. And this is an activity that we'll take a look at next now when we think about possibly creating our own videos. If the videos that we're selecting aren't necessarily aligning with what we need, and or we want to further engage and enhance the student interaction in this process, or more.